Thank you, Dr. Neni. My name is Ushijima Ken from Hokkaido Research Organization, and I'm also the member of the REAM project. Professor Yamauchi already introduced. So today I want to talk about the water infrastructure management technology for population decreasing society. So as he mentioned, we are tackling not sanitation but water supply in Ishikari River Basin, because our tactics is first we want to try to create the value chain with local people for the water supply system. Then after that we will use the similar scheme to the sanitation value chain. So today I want to show some our trial about the co-creating the value chain. But today's this seminar's topic is the application of the new technology. So in this presentation, I want to set some question about relating to the technology application. So in our project also, we always discuss maybe these two approaches. I think you may know that the seeds-led approach and the needs-led approach. The seeds-led approach is most of the technology project is maybe this type. So first you have some technology seed. Then trying to compose the scheme to use and diffuse the technology after the technology innovation. But another approach is the needs-led approach. So most of the practical project is maybe this type. So in this approach, trying to find available technology and compose the technology package after problem was clearly revealed. So we always discuss which should be done first. So through this presentation, I want to mention about this question also. Okay, so let me proceed the contents of our project. So first, I want to show some background in Japan. So what is happening in water infrastructure of Japan? So in Japan, the population decrease have already started like this. But if we look into the situation in detail, for example, here, northern island of Japan, Hokkaido island, our island. So this red part is the expected that more than 80% population decrease. It means the population becomes less than 20%. So in rural area, we can see that the rural area faces especially severe depopulation. So under this situation, what happened in the water infrastructure is like this. So first, this picture is showing the current situation, current structure. Maybe I can say the value chain of the water supply system. The central government and local government, then the people pay the tariff or tax for the local government, then local government manage the infrastructure, then people receive the service. But if the population decreased, of course, the water income is decreased in the local government, and the tax also decreased, so local government also shrinking. So it causes but the infrastructure hardware cannot shrink. So that's why it leads the increased per capita cost. Then it decreases the payment for the local technician, and they cannot keep the business. So this kind of the negative spiral occurs. So in this situation, we understand that it is difficult for shrinking small local government to fight against the shrinking process only by themselves. So to challenge shrinking process, the conventional mindset of full controlled, centralized, managed water infrastructure should be shifted to that of the decentralized, flexible management system. So we shifted our point of view to the different type of this water system. So in Japan, usually we consider the water system, this part, water supply system and simple water system. But historically, we have many small community-managed water systems. But these are ignored for a long time. But we consider that this water system, in fact, they have succeeded to manage their local water system for a long time by themselves. So we consider that this small water system can be one of the promising future models for shrinking society. But so far, we have no information about this kind of small water system. So first, we made some field work to know their management style. Then we made an interview to the total 39 association in Hokkaido. Then briefly speaking, the typical feature of the local community-based water management is first, they're getting water from very good water source. So the water purification cost is almost zero. They don't need water treatment. And also, in rural area, most of the user is farmer, so they have technique and they have machine. So daily cost is quite few, as long as that's the next topic. Most part of daily management are conducted by the community because the farmer have the machine and they can operate them. And the third point is the users are also manager. It means so all users work for water system in some part. For example, every one time in a year, they clean up the water source. So all community person join the cleaning activity. And also the people who fix the water system is also the user. So it becomes easy for users to accept some inconvenience on the basis of the self-responsibility mind. So it enables them efficient management. But we also found some weak point of the local community-based water management. One point is greatly depending on the good water source. So the water resource management is necessary. So it needs the wide collaboration is necessary. But so far, each water community working independently. And another problem is they have no treatment plan. So it means that no barrier against accidental water pollution. So some kind of risk management system and technology should be applied. And another weak point is the unstable asset data management system. It means that, for example, there is no data where is the pipeline is. So only the people remember where it is. So if the manager was changed, the information will be lost. So we thought that what we need is the supplementing system and technology for those weak points of the local community water management system. And we draw some current structure of the water management system. The conventional water management system is managed by local government, but the local community managed water system is managed by themselves. And it's based on the agricultural-based community. And they can use the machine and technology based on the agriculture. So we also found this kind of structure. Then based on that finding, we discussed about the technology. So the new prerequisite of the technology for local community managed water system, for the important player is in conventional idea, the important player was local government and specialists. But in this new idea, one of the important player is farmer, a kind of specialist for the machine and chemicals. And later I will show some picture, but the high school students or retired farmer will be also the key player because they can be good local technician by some small training. And also they can work by small or no salary. And then the important function in the conventional idea is high technology to aim perfect risk control by specialists. But in this community managed system, simple technology for user-involved risk control is important. And also the low-cost tool for building and managing the asset databases. Then we designed this kind of some kind of value chain. The community-based water management system so far works. So we will use this scheme, but we set some supporting players. Then actually we made some trial, but today I just show one topic, one technology. We apply the very simple GIS system to build the pipe network information. This is using the iPad. Then the high school student will enter the information by iPad. Then easily they can make the GIS data of the pipe network. Then we made some field trial, this part. So this is a picture. So high school student asked the water manager, old person, then they inputted the information. And also they visited the field and they made an interview. Then finally they created this kind of the GIS data. Then we had some reporting seminar for the water managers. Then they presented the results, and they also give the results to the water community. Yes, like this. I think you can see that this is the CD-ROM, including the data, and also they are very old persons, so they still want the paper map, so we give both. So the findings by field trial is the first, the high school student could use simple GIS system by short training, and they could provide sufficient quality data for local community-based water management system. And farmers also understand the system and are interested in the system. And provided data was also useful for local government as basic local data. So the local government requests us to give the data. And also their data was also attractive for specialists like researchers. So possibly become incentive for specialists to support local community water management system. Then finally, I want to mention about about this question. So the seeds-led project and the needs-led project. So actually, in my presentation, the first I mentioned about fieldwork and technical consideration and understanding the current framework, then sorting out the technology prerequisite, then I show the designing framework and field trial. But in fact, what our project done is first field work, then goes directly to the designing the framework first, then feedback to the technical consideration and field trial, then again feedback to the another part. So what we had done is very complicated order. So my message is which should be done first is the question is wrong. So I think these two approaches should be go and back many times between these two. Then we have to somehow achieve these results. Okay, that's all my presentation. Thank you.